name is Notlina Binti. I'm from CS1434C. Tuk tuk, honey, it's your turn to introduce yourself. Here we go, catch it.
Adelina, don't you know that it's bad to throw books?
I'm sorry, my mistake.
Assalamualaikum. My name is Nurhani Zahra binti Sazali, and you can call me Hani.
Thank you, honey. Don't fight, honey, Adina. Hi, Assalamualaikum. My name is Muhammad Amir bin Azhari and I am from CS1434C. And now we're gonna do chit chat. What we gonna to talk? Honey, Adina, what we gonna to talk today?
Moment of force.
Moment. Moment is defined as the product of the force and the perpendicular distance from the line of the action of the force from the feet axis, which is pivot. The turning effect of the force is called as moment. For example, the application of seesaw.
This is a balanced seesaw. However, with different weights on each end, it becomes imbalanced. A child's weight is essentially a force of gravity. If one child weighs 10 kilograms, the other weighs 5 kilograms, and they are exactly the same distance away from the centre, how can the seesaw balance again? Since the lighter child is half the weight of the heavier child, you must put her twice as far from the centre to attain the perfect equilibrium. Mathematically, a moment is defined as force multiplied by the arm. Going back to our seesaw analogy, we can prove that the lighter child is able to balance the heavier child by using a longer arm to achieve the same moment of force.
What about the formula?
Oh, I know. Let me explain. Moment can be calculated by using this equation. Moment equals to force multiplied by distance. Since moment is a vector, it has both magnitude and direction, where the direction is usually defined as anti-clockwise or clockwise. More often than not, force is measured in Newton, which is N, and distance in meters, which is M. This makes the SI unit for moment to be Newton meters, which is Nm. Oh, and also remember, the larger the distance, the greater the moment.
But don't tell me that you forgot about the principle of moment.
No, we didn't.
Adrina, how about you explain about the system?
Gladly. Let me explain about the principle of moment. The system is called in equilibrium, or it is to say balance, at rest, or moving in a constant speed. If the total of clockwise movement is equal to the anti-clockwise movement. As Hani have explained about the formula of moment, let me recall again that moment is equal to force multiplied with the perpendicular distance from the pivot. Okay, on the next video, I will show you a simple experiment that can make you more understanding about the principle of moment. Okay, let's check it out. So, let's take a look at a simple experiment which led you to illustrate the principle of moment. So, what we're gonna do is, this is a beam with a pivot here, and we have two weights. This weight is 50 Newton with the distance is 6 meter away from the pivot. Another weight is 30 Newton with the distance is 10 meter from the pivot. So let's test out the principle of moment, that the sum of clockwise is equal to anti-clockwise. So this is the formula. Sum of clockwise movement is equal to sum of anti-clockwise movement. So we got 50 Newton times 6 meter is equal to 30 Newton times 10 meters. So 50 times 60 is equal 300 Newton meter, and it also 300 Newton meter. The unit is important because it is force. So what we can see is sum of clockwise movement is equal to sum of anti-clockwise movement.
How about we solve this question? But how do we solve this? Let us take a look to this question. A uniform route PQ of length 10 meter and mass 2 kg rests on the two supports A and B, 2 meter from the end P and 4 meter from the end Q. A load of 3 kg is placed at the end of P and a load of 2 kg at the end of Q. Calculate the reaction force at both supports A and B. Hint, G represents the gravity.
Okay, let me solve the question based on definition and formula that Ame and Hani have explained. On the next video, that is how I solve it. Okay, so I already draw the question on a piece of paper.
As Ame has stated, the uniform rod PQ is at rest, which confirms that the moments of A and B are equal to 0.
These two reaction force is not the same value. It's different because the problem is not symmetrical. You can take movement at any point that you like, but the best place to take a movement about at A or B, either one. And the reason for that, if you take the force that cross the pivot from the pivot, it is equal to 0 because there is no perpendicular distance from a pivot, because S is the only one unknown in this problem, so it's easier to solve. So I'm going to take about moment at A to be a pivot. So I'm going to take about moment at A for the first to solve this problem. So first we want to find a moment about A. So this become pivot. So this force is anti-clockwise. It become negative S times 4. It's because force multiplied by the perpendicular distance from pivot. So as you can see, S multiplied by 1 plus 3, it becomes 4. Negative, it is because anti-clockwise. So we add another 4 moment plus by 2 times 4 plus 1 plus 3, it equals to 8, plus 2 multiplied by the 3, and the last one is negative 3 multiplied by 2. It equal to 0 because the system is at rest, so it equal to 0. Okay, we solve one by one. Negative 4s plus 16 plus 6 negative 6 equal to 0. So this is 16 equal to 4s. To find s, we move 4 to the other side. So s equal to 4, and the unit is Gn. So we already have the reaction force for S. Now we want to find all the reaction.
Moving on to the reaction of force A, as the question resolves vertically, the resolve equals to 0. This is the clue to getting the reaction
Take
of force
all the
A.
reaction and equal to 0, okay? The first one is RA we don't know, so we don't know the value, so we make it ra plus s is 4, -2 and -2, and it also -3 is equal to 0. So ra, and if you calculate it, and you will get 3 equal to 0.
There we go. The reaction of force A is 3Gn.
Unit, okay? Don't forget about unit.
To confirm the validation of the reaction of force A, Adlina is applying the same method she has used to find the value of S. Moments of B is equal to 0. The reaction of force A is 3Gn, which does not hold any difference compared to the previous answer. We can conclude that the reaction of force A is surely 3Gn.
Ha! How was it, guys?
That is true. That is all from us. Thank you.